Hi, I'm going to be walking through question 9 of the Maths Olympiad. This question is a nice number theory question, and I'm going to be going through one of the solutions. I'm sure there's many others, and I'm interested to see your guys' solutions, but I'm just going to be going through mine real quickly. First of all, we've got this equation here. We've got x to the 5 equals 2x squared y squared minus y to the 5. It's quite nice to have your powers on this side, as they've got the same degree. It's quite nice to have it like this. From this point here, you can basically get rid of the x squared y squared. If you divide both sides by x squared y squared, you get the following equation. Notice this equation and the original one is symmetric around x and y, so you can swap out x and y and they'll be the same thing. So these are symmetric, and we can factor out an x to make this x squared over y squared, and we can factor out a y to make this y squared over x squared equals 2. So these two terms here are very similar. One is the reciprocal of the other. So we can say the substitution that t equals x squared over y squared. Then the following equation will be plus y over t. This is the same thing as y times the reciprocal of t, is equal to 2. You can follow through on this, and let's just write this like this, equals 2, and you can multiply both sides out by t to get the following equation: xt squared plus y equals 2t. Now you've got a quadratic in t. So if we rearrange this quadratic to the following: xt squared minus 2t plus y equals 0. With this following quadratic in t squared, well, we're looking for rational numbers that satisfy this equation. So if the roots of this equation are rational, then recalling the quadratic formula, minus b plus or minus the square root of b squared minus 4ac over 2a. If you've got a quadratic, and this is a quadratic in t squared, then and the quadratic has rational roots, then the square root must be a perfect square for this equation to be rational. If it's not, then they'll have irrational roots. So from that we can say this here must be a perfect square. The discriminant of this equation must be a perfect square. The discriminant of this equation is minus 2, so that's minus 2 squared minus 4 times a, which is x, times c, which is y, and this is a perfect square, so we can say this is a squared for an integer a. 4 minus 4xy equals a squared. If we square root both sides, well, we're just going to get square root of minus 4xy. You can factor out a 4, so it becomes like this, 1xy. And we can see as this is a perfect square, and 4 is a perfect square, then 1 minus xy must be also a perfect square for the whole expression here to be rational. So this is 2 times the root of 1 minus xy, but we know from above that what we're looking for is 1 minus xy is a perfect square, and for this to be rational, then 1 minus xy must be a perfect square. So there's a nice proof.